Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 495. In this episode, Scott talks with Dawn C. Hayes about the intersection of physical computing and creative coding.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and right now I'm talking with a coder, tinkerer, and adjunct professor, Dawn C. Hayes. How are you?
Great.
I appreciate you coming on to talk to me today. One of the reasons I wanted to talk to you was because it feels like in your work you're exploring not just coding, but the intersection of physical computing and the creativity of programming, and thinking about it in ways that I think a lot of people haven't thought about it before.
I think that was definitely the case when I first got started, which was around 2009. I think then it was more about just letting people know how basic things work. Like, this is a microcontroller and this is an LED and this is electricity. And I think now, so many people are hearing about things like MakerBot and, Arduino and Raspberry Pi, and it's become super trendy now. So, well, maybe not trendy, but more into the mainstream now. So, it's less of a difficult thing to have a conversation about, hey, we should start incorporating this into wherever our learning environment is. So,
do you think that nerds are still a thing? Like, I remember in the 80s, if you had a soldering iron, or in the 90s, if you had a garage full of stuff, you're a little weird. You visit someone's house,
right.
You see their space, and then you see the clutter, and everyone's clutter is different.
Right.
There's a certain kind of, stereotype of, oh, you're one of those people. You're in the garage.
Right, right.
Evil scientist, I think was the word
right.
I was looking for. But now I feel like there's a lot more stuff to make and there's a lot more tools to use.
Definitely. I think nerd is kind of sexy now, right? So, I mean, you've got Big Bang Theory, you've got people looking really good. When I was growing up, and I was definitely a nerd, I was not cute. You know what I mean? Like, when you were a nerd in those days, 80s kid, you really look like a nerd. And I think today it's chic, it's trendy. Nerds are probably more manicured than they had been. But I think the interesting thing out of that is, it's now cool to be smart. It's now cool to actually know something that maybe no one else does. Like, today, your rock star is considered like a coder or an entrepreneur. Not just a person who bangs on the drums in their garage. So I think that's been great. I think some of the reason that that's probably become the case now is because we have more people who are actually interested in reaching out to a greater audience. So, in my case, I teach a class called Hacking and Building, in City University in New York. And I expect that most students are going to come in not having had any background at all in electronics or programming, have no idea what a soldering iron is, don't even know where to get these parts. And, but they're interested because, the first thing everyone asks me is, oh, so we're going to break into the FBI or CIA, which, that's, always, I can neither confirm nor deny that. But I think that because we're starting to see, the nerd is now, super rich, right? You think of your Facebook founder, even Microsoft. And, people are curious. They're thinking what can I build next? And you have more opportunity in the form of hackathons and in the form of contests and in the form of Kickstarters and crowdfunding. So it's getting open now so that it's not a matter of so much can I do it, but what do I want to do and what resources are available to me? So I think what started out maybe seeming like, okay, be here today, gone tomorrow is now just almost expected that some aspect of what you're doing or what you might do, whether it be, you're going to go to school and then do a computer science degree, or you're going to be a full web developer, will have some aspect of kind of the nerdy factor, but in a very cool way.
Mm-hmm. So I want to dig into what you said there, is that when people come in, they don't necessarily have the preconceived notions maybe that we did in the past. They're like,
right.
Oh, okay, this is how this is done. And they jump in. You're teaching people from all walks of life, who come into your class.
Yeah, I mean, the average student is probably traditional college age, so anywhere between 18 and I get a few seniors, so 22, 21. Mm-hmm. The courses are required, so I don't want to make it sound like it's just so exciting. Everybody's just jumping into it.
So it's not self-selected, like, hey, I'm going to build stuff.
It's not self-selected if you are a communications technology major, but I do get quite a few students who are not majors who take it as an elective. And what I find is that most of them, if they've read the syllabus, are still not quite sure what they're going to encounter, but they're excited about this idea of like repurposing something. And then most of them have heard of 3D printing. They've heard of things like MakerBot. So they're really excited about getting into digital fabrication. When it comes to things like physical computing, making your own, interactive wearables, or even talking about some more, emergent technologies like Bluetooth Low Energy. That's the kind of thing that we delve into maybe about halfway through, once they've gotten a confidence that they can suddenly know what it means to, cause an LED to light up, polarity, things of that nature. So, the first exercise I do for a lot of students is just have them bring something in that, was old or dusty, hopefully not their little brother's toy, and just tear it apart. And it's really interesting sort of the expressions and the response, because a lot of them are like, wow, like I didn't know all this was in here. Sometimes it's very simple stuff. So they're like, I didn't know it was just these few parts. How does that work together? But, I think the bridge between seeing, what at one point looked like just this thing that I'm not concerned with what's inside. I'm just consuming this. I mean, they don't say it that way.
It's a black box.
Exactly. And then having the sort of, the reality or reasoning all of a sudden that they can actually build something like this, even if it's a rapid, flimsy prototype, it excites a lot of them. Some people, end up deciding they want to continue on, and some say, it was the toughest course I've ever had. I'll never do it again, but I'm glad I passed, and I'm glad I got to demo what I made. So.
Now, I think for some people who are listening, they might be thinking, gosh, someone made it to 20 years old and never took something apart. When I think a lot of us, I always use the example of the clock radio, like the born nerd takes apart the clock radio when the mom and dad aren't looking. And then if you're lucky, you put it back together and it still works. And then nobody hears about that.
Yeah. I was one of those kids who took a lot of things apart. I can't say I always put it back together again where it worked, but, one thing I think that's what's happening is, to speak to the point about some people have never even had that chance until later in life. I got to do that real early, and for a while, I thought I was going to become a scientist, an inventor, or an entrepreneur. It's like one of the first words I learned to spell, which is pretty funny. And, by the time I got to college, it was more of a conversation around, you need to do something practical, right? So this wasn't in the 2000s, and, I graduated around the first .com wave without giving my age away. So, but, there was no thinking that you were going to do this. If you did want to do something like that, you're going into, an engineering field, or you might study computer science at the academic level, and maybe do something for a company that just wasn't as open to where people could really understand what they were doing. So I think that having the opportunity to play and to figure things out, and then to realize that you could actually make a career of it, is also what's turning a lot of students into, soon to be or future makers. They realize that I could be Sheldon. I could also be Mark, but more importantly, I could be me. And here's how I want to plug in. And, what I'm really hoping will happen is, just the idea of not just doing this within a space of the four walls of academia, which is great because you get to play and prototype and kind of fail in a safe way, but taking this out into communities where people, just like you said, may not have had any exposure to this until maybe they're 40, maybe they're 60. My mom is probably the biggest influence on me as far as being a maker is concerned. She doesn't do the tech stuff, but I mean, almost everything she's built. And, some stuff looks really great. Some stuff could use polish, but it's just always been something that I've been around. And what I realized was that, whether you call yourself maker with a big M or maker with a little m, it's really invention, right? It's really play. It's really creativity. And the current generation of students that I encounter, a lot of them really just haven't had that exposure. So if you sit them in a room for 10 minutes and you say, okay, look, here's a box, a paper clip, and a toothpick.
Right, MacGyver scenario.
Yeah, right. Make something, And it's amazing how they look at me and they're like, oh, what could I do? I mean, there's this idea that it has to look a certain way. And I think that in academia, because a lot of the programs, I mean, even starting a program like Hacking and Building or a course like that, just trying to break students out of the traditional experience. You take a quiz, you take an exam, your final exam. It's an amazing, transition. So I found a lot of times those that I encounter, they're not used to giving a demo at the end of a semester. They're not used to, something not working and it being okay. And what I found is that if you can bring some of that outside of the traditional academic environment, it's a little bit more encouraging because I think people feel a little bit more safe to fail. It's not like you're going to worry about failing or not receiving a good grade because it's your project. It can be whatever you want it to be. And I think that's an important part of the culture that I'm hoping to dive into full time.
I think that concept of safe to fail is so important for early learners, whether that early learner is 7 or whether that early learner is 22.
Sure.
I've been struggling with that with my kids. I've got a 7-year-old and a 9-year-old, and the 7-year-old still has this idea that he's supposed to get it right on the first try. Mm-hmm. And right now we're 3D printing a quadcopter, and I have no idea what I'm doing. You know what I mean? Like I have a PDF and a bunch of 3D print, and I'm sure it's going to suck, and it probably will never take off. Right. And I keep trying to remind him of that and he's like, no, it's going to be awesome. Like, we're going to be flying it around. Yeah. Like, no, we're not. It's probably going to take months. So there's two things there. There's the safe to fail, but then there's this is not something we're going to do in a weekend. This is going to be, next year we might pull this off. Who knows?
Absolutely. It's funny because the same experience is what I've had with a lot of my students, and it's amazing how they actually get frustrated because, again, going back to sort of a traditional learning experience, that's the expectation. Whatever you do needs to be an A+. Whatever you do must, So, I think another part that's really key to this is creating a culture. So, my students, we walk in first day, I'll show them I hope I don't get fired for this, the official syllabus. And then I'll say, okay, and now here's what we're really going to do.
Yeah. I was an adjunct. I've done that before.
Okay. Yeah. And I think you have to make sure that you're also, meeting your expectations and meeting your goals and requirements. But, I think the minute they recognize that it doesn't have to be pretty. So an example, I showed a project, done by Casey Kinzer some years ago called Tweenbot. And the idea was it was an interactive robot, but it was not smart. It was like cardboard and a motor and some wheels. And, she puts this thing out in a park in New York City. And this is, post 9/11. So putting things out in a park is probably not you don't know what kind of results you'll get. But, she puts this out there and the only prompt that's on this robot is a little message that says, hey, can you help me get to the northwest corner of the park? I think it was northwest. And the idea was to experiment and see, hey, are New Yorkers, somewhat polite, or are they, as mean and antisocial as people think they are? And it was actually a really cool experiment. She went on and did some TED Talks, and it was, people really liked it. But what stood out in the minds of my students and what I was trying to explain to them was, with all respect to John Ivey, like, it doesn't have to be iPhone 6, right? Your first try, your 50th try, design's important, aesthetics are important, but it absolutely does not have to be what you encounter in your first, maybe even your 50th try. And once you can get past that, then you're free to take your building blocks and make really great things. And then you can go back and reiterate it and make it look pretty and nice and, put it up on Kickstarter. So yeah, that's always a challenge. And I think that, documenting that too is really important because people see where they've come from. Like, they see how, really rigid they were. And then they're like, there's only 2 weeks left before I have to get a demo, whatever. Let's just get it done, but it's also been a learning process that they actually, benefit from because it is safe for them.
I think that you've made a number of really good points there that I want to touch on. First, the documenting it thing. Like, I follow these people on Instagram, these fitness people. And while I find selfie culture obnoxious, the fitness people do it in order to see progress. And this is a standard working thing.
Right.
They prep, they measure, and they cut and they repeat.
Right.
And I think we as engineers have a tendency to just zip up a version or commit it to source code.
Right.
We're not nearly as regimented. I think we could take something from that culture and start looking at a project and see that, hey, look, this actually did move. It didn't feel like it was moving, but if you look 6 months back, it made a difference.
Right. Yeah, I mean, and again, whether you're in a traditional classroom, you're in a makerspace, or, you're in your basement, that's part of the process. A lot of the students and even some of my non-students, when I first would introduce that we were going to document everything. And I have to admit, I have maybe 12,000 images and videos sitting on my laptop that have not made their way to the social media. So I'm definitely a hypocrite when it comes to that. But, as far as the student's progress is concerned, that's important because, it's easy to feel like I should go from step A and be at Z in 2 days. And I think the first thing that students learn is whatever you think is going to take 20 minutes is going to take you 4 hours. And whatever's going to take you 4 hours is going to take you maybe a week, right? Yeah. And so you start to learn to manage expectation, but you also have this periodic encouragement, because you can look back and say, okay, I did make some progress. It's not quite what I was expecting, but I did make some progress, right?
This is a really tough lesson for people to learn, though, because we, myself, yourself, and people who think like us, I've just put us in a group, by the way, in case you didn't notice, want to go out there and getting people to turn that LED on as fast as possible so that they have that moment. Then we say, okay, that was great. You got an LED to turn on. It only took you 10 minutes. Now your next project is going to take you, 6 to 8 weeks, and the next one's going to be a year. Right. So I think people get spoiled. They can go and type something in a command line, and they've got a Ruby on Rails blog in 2 seconds. Now learn to code. It'll take a year. Right. How do we teach that patience?
And that, to me, is just have as many different experiences as possible. So one thing that I've experimented with is students get to work on their own individual projects, but then they also have to complete a lab. And at the same time, as they get towards maybe the last 4 to 6 weeks of the semester, they then have to work collaboratively. So what I found is that when you work in a group, well, do I need to say any more, right? When you work in a group, but when you work in a group, you have to learn to work with other people's pace. You have to figure out who's going to do what. And, if somebody slacks off, the project still needs to get done. And in my courses, everyone earns the same grade, but then I have a separate metric to measure people against themselves. And measuring people against themselves is really important because it keeps people from, feeling like, I should give up because this person's way better in programming than I am, but this person's, way better at arranging a circuit or figuring out why there's a short. So I think being able to measure yourself against yourself is important. I think the other part that probably has worked well in helping people to become patient is it's one semester. And, if you find that you like this, you can continue next semester. If it doesn't work in the semester, you can go hang out at a makerspace or, chime in on a challenge post. So, just getting people involved in different experiences so they see that the process of making something from start to finish varies, depends on what you're doing, what the setup or parameters are around that, and then even your teammates. Even when you're working by yourself. For me, I know my biggest problem is procrastination. I do not like pressure, but for some reason it always comes down to oh, there's a week left. You need to get it going. So
yeah, it's always 2 a.m. the day it's due for me.
Exactly. And then that's when everything fails. So, those little lessons help you learn about yourself, and they also help you figure out, am I the type of person who needs to plan everything? And if I do, I learned that not everything's going to work as planned. And if I'm the type of person who, just takes it in stride, I realize more structure is probably going to help me create a better product or project. And also, feel good about myself because I got it done. So I think all those things play into helping people to be more patient. Yeah. It's hard because we live in a push button society. So the idea is push and it's there. It's a challenge.
Hey folks, I wanted to take a moment to tell you about Raygun and their new product called Pulse. Ray Gun is an error and crash reporting software provider, and their new product, Pulse, it's a real-time user monitoring product. It gives you performance data and user insights. Lets you understand exactly what's happening when users interact with your software, so you're never left guessing. Ray Gun provides you with the answers to your performance questions, and they've found over 10 billion, that's billion with a B, bugs in customer apps with their crash reporting product. And now Ray Gun will help you understand application quality like no one else. Over 30,000 developers worldwide can't be wrong. I use Ray Gun all the time, and I enjoy it very much. You can try it out today with a no-risk 30-day free trial. Start improving your software quality immediately. Try Ray Gun for free today at raygun.io. I had Keisha Rogers on a couple of months ago who's talking about systems thinking and how we spend all this time trying to teach people how to code, but not how to think about systems.
Right.
And while you were saying what you were saying a moment ago there, I realized that what I do with any large project, whether it be a coding project or a larger creative project that spans the physical and the software, is it's not just breaking things down into functions, it's breaking things down into tiny victories.
Yeah. Wow. I like that. Okay.
So like, I got to break this into a function. I'm like, no, I want to break it down to something that I can succeed at and go, yay me.
Right.
Like I made the worst soldering joint yesterday. It was like, I just basically got halfway through it and said, screw it. And then I just duct taped the whole thing. I'm pretty sure it's safe. Like it's only 5 volts. I'm pretty sure it's not going to burn the house down. But basically I'll just give it's a very small story. I'm trying to get this 3D printer to plug into an ATX power supply so I can have the heated bed.
Okay.
And right now I have one thing plugged into the wall for the Raspberry Pi, another thing plugged into the wall to get 5 volts to the printer itself, and then another whatever watts for the bed. So I've got 3 things plugged into the wall. And I've got this ATX power supply, right? So I decided I'll just leech power off this. So I strip the wires off of the USB cable and I start figuring out which is 5 volts. And I'm like, how do I not die? And it looked like a big problem. Like I'm not a real good hardware person. But I was like, okay, let's just break this down. I'm just going to solder these 2 wires together. And that's today's tiny victory.
Right.
And I'm going to check this with a multimeter. And that's today's tiny victory.
Right.
And even though I ended up just using electrical tape in the end, it works. I plug one thing into the wall and it powers all 3 and nothing has burst into flames yet.
Thank goodness. Amen. Yeah. And I think that's again where I go back to the point of like measuring yourself against yourself. Right. And having those little victories do help, and knowing that that's a victory, right? So like
knowing it's a victory.
Exactly.
Yes. Thank you for that.
Yeah, you're welcome. I think you inspired me, but yeah, I mean, definitely knowing it's a victory because again, when you're getting started in this stuff, you don't know, right? Like you don't. Literally, when I start a soldering exercise, students take like a piece of wire, loop it, and solder the 2 ends together, and they're so excited, And I say, hey, go take this home. Now, that works really well with my 7-year-olds. I wasn't really sure if it worked with my 20-something-year-olds, but you'd be surprised. They are all excited. I want them to come back to me and say, hey, look, I still have the little ring that I soldered. So,
you make them solder a ring with a that's
literally, cool. Yeah, it's
that's a good idea.
Yeah. So the guys like it too, but
this gets down to a recurring theme that I've talked about on the show over the last year, which is this represents power.
Yes.
Whether we're talking about new people in technology, whether we're talking about underrepresented people in technology, whether they're young or they're old, the reason that this is important, the reason that maker with a capital M is important is power with a capital P.
Yeah, absolutely. I mean, like I've been alive for the entire existence of the world, but I think this is probably the best time to be alive because there is so much opportunity. There are so many resources. So, before we started this podcast, we were like joking around about grad school and finishing and paying for it, right? So this was my motivation when, I attended a small college in Ohio. It was a family school. What that means is your sibling goes to school and then you go to school because you're on scholarship and they're on scholarship, and it has nothing to do with whether you want to go there or not, right? Like I fought my parents for like a year.
You mean you got grandfathered in or something?
Yes, I did. It was great. But it wasn't the school I wanted to attend. Nevertheless, when I graduated, I thought I wanted to work on Wall Street. So I start teaching myself finance. Keep in mind, this is a very, very small school. So they had no finance program. This was right around the time when people were starting to get interested in financial engineering and eventually want to do quants and all stuff. And somehow I thought that's what I wanted to do. So I ended up going to Columbia for a while, and just like a semester was ridiculously like cost prohibitive for me. I could not afford it. I worked hard and I would pay for a semester. I ended up going for like a year, and I was like, I can't finish. I can't even get into the program. I can't afford it. Same thing with ITP, $80,000 awesome grad program at NYU, but pretty expensive for most of the people that I'm connecting with. And it suddenly occurred to me, because one really nice thing about ITP, interactive telecommunications program at New York University, one really nice thing about them is they put everything online. They're very open. They're basically like MIT Media Lab. So they focus on a lot of the recent or newly emerged technology, and they do it within the context of art. So it's a very nice place to play for 2 years and feel comfortable and feel safe if you can afford it. And, what I took away from the program, I didn't finish, but what I took away from the program was amazing support, extremely open in terms of sharing knowledge. And it dawned on me that, like, why can't this be anywhere? You know, why can't this be everywhere? There's really, I don't want to say it's not rocket science, but yeah, it really isn't. And that's where this idea of like breaking beyond the four walls and making every space a maker space and creating a culture around being collaborative, being open, be objective around learning. Because the most important thing I think you can start with is first building a culture that says, I can. And then saying, okay, now what resource do I need access to? And, you know, when you're doing these things, a lot of times no one is an expert, right? So you have the opportunity to, get in early and become your own expert, so to speak. So going back to this idea about making and why it's such an exciting time is, maybe you didn't do so well in high school in calculus. Maybe you know, like took pre-calc 4 times in, you know, college because you were, I don't know, a sociology major and you didn't have to do it, but you need to graduate. All those things, as helpful as they can be, especially as we start going more into computer science topics, it's still not a barrier. You know, you may go so far before you need to start delving into some more advanced topics, but it's literally democratized how you learn around engineering, how you learn around programming, coding, how you learn around making. And to make that equitable, I'm trying not to be too PC, but to make that equitable, you need people who are willing to say, okay, maybe I'm not going to spend half a semester, a full semester at a university teaching this stuff, but maybe I can document this online, and maybe I can, you know, run this in a place like General Assembly or my local church or my coffee shop. You know, when they don't have peak hours, maybe I can take 5 people and just show them how to do it, or do a hangout on Google Groups. Yes. So more people thinking about this and being willing to step out, whatever they know, right? You don't have to necessarily know everything about Bluetooth Low Energy or blockchain, but whatever you know, like, let's take this and now let's fold this into a wiki. Right. Let's get people pair programming using Atom, like just these very open resources to make this reality.
Yes.
And then open it up.
Very similar ideas about this, because every time you learn something, if you don't tell anyone about it, then
exactly. What good is that?
Congratulations, but that's a little selfish, you know?
Right.
I always say, if you learn something, put a URL on it.
Sure. Yeah.
And it doesn't matter where that is. Wiki, blog, God forbid, SharePoint, somewhere that you can then say, look what I learned.
Right.
Videotape it, take pictures. This comes back to what you said originally about documenting.
Right.
It's not just for yourself, but it's also for other people. And I think that, people look at me sometimes on my blog and say, oh, he's an expert. It's like, no, I'm a professional amateur. I just been documenting it for a very, very, very long time.
I know what you mean. Sure. Yeah. I mean, it's what did I used to call myself? A specialized generalist, right? That's my way of not saying that I know absolutely nothing about, whatever. I mean, just right. You play and you try. And, for me, I think that the thing you need something to motivate you too, right? So what motivates me is, I'm a New Yorker, right? So I commute by bus and train. I live in Queens. I know, not sexy. But that's the case. And, you wouldn't know anything about this, God, I know. But, you drive, I'm sure, or bike. But, around here, it's not, it's not bad to take public transit.
Hey, I'm from Portland. We're all about public transit.
That's true. Or biking, right? Okay. Or biking. But, so there's this intersection, it's a major intersection, and there are several buses that serve each angle. And there's a lot of seniors that take the bus. And repeatedly in this one particular intersection, there's always at least 3 people who are trying to cross against the light to make it to the bus on the other side of the street. They're all going in the same direction. These all go to like a major depot. Because, you're kind of playing a game of chicken. You're like, is my bus going to come here, or can I wait for Q5, or should I get on the 84? And, we're so tied to like our mobile phones and wearables, and that's okay. That's sexy. But, what about the demographic of people that use the bus that generally probably don't have, the latest, greatest OS on their mobile phone, or maybe they don't have their mobile phone at all, or maybe they just don't even know
to ask that question.
Exactly. Should that information be something like, when is my bus coming and where, should only be relegated to the mobile phone? So I would say no. And I think also because just a good percentage of riders don't have access to the technologies that the MTA was developing for, like iOS as opposed to Android. So I started thinking about network public artifacts, and it was like, well, what if your stop sign or the bus stop sign lit up when your bus on your route was near you, right? And if you have more than one route, how would you know? So, blink within 2 stops, keep blinking. And then if you don't see anything flashing, you missed the bus, right? Most people know generally how far apart these bus stops are. So they know, like, if I see it blinking, I could run, I could walk, or I'll stay where I am. And
it's surprising that these things don't, like, this is such an obvious, brilliant idea. Like, why isn't the entire bus, what's it called? Like when it's raining, you're in the bus shelter.
The shelter, yeah.
Why doesn't the whole shelter flash? Why aren't there LEDs instead of a white light?
Exactly.
Like, why isn't it a connected shelter that's blinking the bus is coming?
Right. Well, here in New York.
That scales more than a $600 iPhone for everyone.
I totally agree. In New York, there's a lot of politics around like who owns what. So there's Department of Transportation. I shouldn't be saying this, but MTA, love you guys. But there's a lot of politics around it. But what's been really nice is with our current mayor, he's been very interested in a connected city. So we have something called NYC Big Apps. And the whole point behind that, the 4 major talking points, one of those is connected cities. So I think it's a little bit of timing, but the really awesome thing, just tying this back into opportunity and everyone is makers, is there is no minimum requirement for submitting an idea and having the opportunity to be incubated by the city of New York on this project. So this idea could be something that I can work on. It could be something you can work on. We can contribute in GitHub, whatever. It doesn't matter. And I think that what's missing is not this opportunity, but who do we want to include in the conversation that isn't online necessarily or isn't on GitHub, right? So the more we work out these channels in the ecology that will help people know about these opportunities regardless of where they are, right? Regardless of whether they're in school, and that's why I know about big apps, or whether they're at Civic Hall. These are just local resources. That they'll have an opportunity to say, okay, I want to get involved. And then the next step is you open it up to the lowest or least common denominator of skill and expertise, which means that you shouldn't have to be a developer or a programmer. You don't have to be an engineer. You just need to be a user of the transit service, right? And then from there, you can think about these things. So when you have these collaborations and you have the ability to post your idea on something like Big Apps, and there's a potential to collaborate with others and then to receive some kind of support for it, I think it incentivizes a whole group of people who, first of all, it's for them. That's why they'll be interested in it. But it also incentivizes them to be involved in the actual design and development, as opposed to, okay, well, I'll just wait until this is done by the MTA or DOT, and then I'll be happy to use it, right? Which doesn't work that way. But This is the opportunity we have now. You didn't have that before, right? And it's also early that there's no one that can say, well, we don't know if we really want to go with your model because such and such is an expert. Who's an expert? Like, who's an expert in blockchain? Who's an expert in Bluetooth Low Energy, right? They're still relatively young technologies, even though, we have quite a few meetups and other opportunities where corporations are supporting these things. But it's a vast frontier. So to start with an LED is like the spark. And then the next step is, where do you see an LED wherever you are, whether it's your house, whether it's your park? And then now how do we take what we've learned, just the basics, right? And then build upon those things to make it happen. Stoplights, bus stops, whatever, trash cans that talk and tell you I'm full, like empty me, whatever, right? But these are the things that are important. And it starts with, just what we've been talking about, culture around it, the resources, the openness, the documentation, and managing expectations.
So now you're making me want to go put an LED on it. like what can I go and put an LED on? Because it's such a more scalable way of having a connected city than it is to connect all the people with expensive supercomputers in their pocket.
Yeah. And I think that the other thing is this is an amazing opportunity because if we can convince, and I think that we probably will with this particular competition this year, but if we can convince people of exactly what you said, we have an opportunity. I think the proven, resource is, well, by such and such year, everybody's going to have a mobile phone. That's true. But not all mobile phones are the same. Not all operating systems are equal. What might seem like a very small bill. I remember when our president was, supporting the low income phones, and he was like, yeah, and even healthcare for the price of a cell phone bill. And I kept thinking to myself, well, wait a minute, whose cell phone bill? Because some cell bills are like $40 and some are like 200 and change, depending on what you've been doing, especially if teenagers. So, we've got it's right now it's corporately viable to use what exists, right? To use like the iOS and Android platforms, but that's consumer tech. So if we can get more people interested in, I guess I call it consumer to consumer. It could be business to business, but you having a hand in prototyping the future of your city, I think that's how you gain traction. And that's how you get the support of companies like an AT&T or IBM. They're all looking for this. Like I sat in on like a really, really awesome workshop and I was amazed. There's like 50 people in a room in a city of like 8 million people, right? So the point is that there's definitely more room for people to get involved. We just have to be willing to, break beyond the four walls. I love academia has paid me, but we have to kind of get beyond that. And I think this is the time that we have the ability to do that.
People who are interested can check that out at bigapps.nyc. That's the really nice, top level domain, bigapps.nyc.
Yes.
That's very cool. John C. Hayes, thank you so much for chatting with us today.
Thanks for having me.
This has been another episode of Hansel Minutes, and we'll see you again next week.